We plan to finish the presentation around 1:30, and then there is half an hour for questions and answers. Online audience will be able to use chat facility, so you can post your questions even during the event. You don't have to wait until the presentations are over. If your questions are not answered during our event, they will be answered by our speakers later by email. So today's title of today's seminar is Development of Post-Occupancy Evaluation for the Evaluation of Innovative Low-Carbon Social Housing. This is a feasibility study that was undertaken by Mackintosh School of Architecture and John Gilbert Architects. So today we have speakers from Mackintosh School of Architecture. They are Dr. Tim Sharpe and Matt Bridgestock, and also John Gilbert of John Gilbert Architects. Our first speaker today will be Dr. Tim Sharpe. Tim, please do come.
Good afternoon, welcome, nice to see you all here. As Branka said, all three of us are going to speak, so we'll try and keep this sort of informal. We're just really trying to prove to people that it is actually live and not incredibly scripted, so we might go off topic slightly. I'm just going to give a very brief introduction. This feasibility study was looking at developing a methodology for post-occupancy evaluation, particularly for low carbon housing and particularly for social housing. The problem being that we're not getting a lot of information about how houses are performing, and we need to get that information in order to feed back in the design process, in order to kind of inform occupants about how they may change lifestyle, and also to help associations deal with how they might kind of manage properties and so on. So the feasibility study was really looking at how we might do post-occupancy evaluation in quite a kind of quick and dirty way. Because we need to do it effectively, it needs to be easy, we need to be able to get people involved, and we need to be able to get results out kind of reasonably kind of quickly. So that's what we're going to talk about today. We're not going to talk in a massive amount of detail about, in a sense, the findings of the POE. We'll talk a little bit about that because it's quite interesting. But it's more to do with the approach that we wanted to take. So I'm director of the Mackintosh Environmental Architecture Research Unit. We're based at the Mackintosh School of Architecture at Glasgow School of Art. We've been involved in research into environmental architecture for over 14 years now. It actually goes back a lot longer than that in terms of previous practice experience. We're interested in this in a place which is somewhere between architecture, it's somewhere between the people who inhabit architecture, building users, and it's somewhere in between the sort of science and technology of how buildings kind of work and are used. So it's to do with energy, it's obviously to do with environmental performance, it's to do with, with effective architecture. We are a very active unit, we've expanded quite significantly in the last few years. We've got 16 projects in progress. At the moment, over about £1 million worth of project funding. We've been involved in lots of projects over the years, mostly around housing, not exclusively so. A lot of these have been research and development, some sort of core research, some applied research. We have always been involved in forms of monitoring and analysis, and that's always been an absolute fundamental thing that we've done. Our earliest project was East Hall Solar Demonstration Project, which is this one. You may not be able to see it, a bit small up at the top here. Done about 14 years ago, Glasgow's first solar demonstration project, at a time where you sort of mentioned Glasgow and solar in the same sentence, and people did sort of laugh out loud. Of course, that's all sort of changed significantly. But a big part of that is that these sorts of projects, you need to go back and look at the results. It's one thing doing experiments, trying out different ideas. You've got to go back and look at the results and see what worked, what didn't, and then feed that into the process. And what we think is that that's not happening enough, particularly as we're into a place now where we're dealing with a lot of innovative housing. Because of the push for low carbon, low energy, it's becoming part of regulations, it's becoming a big part of society. That's leading to a lot more experimentation, if you like, a lot more innovative design, a lot of new techniques, changes in regulations and so on. So we think it's important that we would start to learn from that process, because as we go through the next few years and regulations change, it's important that we get that information out, that we can feed it back into the kind of process. We wanted to do this project with an architect who was doing work in this particular area. So I'm going to hand over now to John Gilbert, who's going to talk about his sort of rationale for being involved in this.
Welcome. We're pleased to have been associated with this project because we have long felt the need for practical information, real information about our buildings. We have, as a practice, specialized in social housing for the last 30 years. And although we carry out lots of different housing and we improve all the time towards the building regulations, the new standards, getting feedback over the houses is often very difficult, and learning from them is difficult. I think one of the things that we try to do, and you can see in the little cutaway here in the bottom side of the picture, is a very simple questionnaire that we give to all our tenants once we've completed a building. And it's really to try to get a feel of their satisfaction with the house and what might be wrong with it, if there is anything that's wrong with it. Now, this is done within the defects liability period, which is the 12 months after we've handed the houses over. And the advantage of that is, if there is something wrong, then we can get the contractor back to adjust things. But we often find that it's a result of tenants maybe not understanding the controls or the way the system operates. So it's this. This is one of the things that interests us, is how we communicate this to tenants and how we can design systems and our houses that are easy to understand and will adapt to a whole range of different households that we get. So I think we'll just move on to, as an example of some of our projects, the top right there is in Fern Hill, which is one of the areas we looked at, which are fairly high standard of energy efficiency, better than the basic 2007 building regulations, but fairly standard house type. The one below that, two below that actually are in Leach Street, which again, high standards of insulation. That would meet eco homes very good, which is common and a requirement throughout the Glasgow area. And the large picture is of Bank Hall Street, a dementia home, which uses passive solar and active solar, which again, nice to see it common after East Hall, is well worth it in the Glasgow, in the northern climes. But although these, we look at these from a point of view of the BRE, that is not retrospective. What we need is information in terms of the user's involvement in the building and how it has succeeded. And that's where the need for POE comes in. And of course, there's no actual requirement for post-occupancy evaluations at the moment. But we would like to see it much more integrated into the building regulations, perhaps with the new sustainability labeling system. So why will we take it on? Why, one of our concerns was that it was too complex, really. And so we wanted to make it much simpler for people to do, and quicker and short and simple, and to get feedback. So obviously, the objective assessment of project aims, it is not our view. So much of what we have is maybe not so much hype, but it's saying singing the praises of a building because it's got this, that, and the other thing. It's actually knowing what happens in use, and it's by a third party, university, great, who's independent and isn't influenced by any other views. it's going to improve our knowledge so we can change the systems to adapt. Unless we really know the reason why things are failing or not being successful, we can't change it. We just go on doing the same thing again and again. That's not the way to innovate. We've got to understand where the quality of the finished product can be improved. And this is just simple things like workmanship. And obviously that is changing with airtightness testing, but it also affects a number of other things in terms of the fitting and installation of mechanical equipment, which is more to the fore now. Understanding the user's needs better. Well, there's quite a reservation amongst users about using mechanical heat recovery systems and just controls generally. And so, you know, they'll open windows or not open trickle vents or use it the way they want. Fair enough, it's their house. But if they don't have the knowledge to do it, then how do we change that? Or can we change that? And should we? And also we want to demonstrate the results to future clients. Why is it useful to clients, most of whom our clients are housing associations and councils? It gives us real data about the building performance against the design criteria. Everything has a SAP rating, but we want to know exactly how many kilowatt hours per square meter it is actually taking. And this is important if we're going to reach the not just the 2010, but the 2013 standards, the whole Sullivan report and how we're moving to zero carbon. POE can assist in identifying areas where future stock can be improved. So it's not just new housing as well. It can identify areas for improvement in design guides. Communicating this to tenants, I think, is a very weak point and something that Matt has also worked on for the project at the Glasgow House, which is part of the sustainability labeling system, where we've got to be able to communicate how systems work. And in older properties, assist in prioritizing the areas for rehabilitation and renewal. Useful to clients and the users of the building, well, educate the residents in the efficient use of their house, reducing their energy bills. You know, that there should be an incentive to that. They don't always know what it should cost. And of course, we find with very energy efficient housing that the internal temperature rises and people are still paying the same amount as they did before because that's what they can afford. So in a way, they heat to what they can afford. But they probably could save if they knew a wee bit more about how the building worked or how the system worked. Identifies further information in tenant handbooks and for training, and supports implementation of sustainability and quality assurance policies. The process in, you know, when can this operate? Well, for new build, we think it's ideal after about 6 months. Obviously, it is better over the heating season. And although you can't get a whole year's data for the heating of the building, you can record what the meter is at the start of the project and at the 12 months at the end of the project. So although you go and do the analysis midway, and the purpose of doing that is that you can get the contractor back then and adjust anything. So you're finding out anything that needs adjusted. Often very important for things like Bank Hall Street or where you've got communal heating systems where things are just not set correctly and they need rebalanced heating systems. So undertaking a short POE would be well worth it. Making adjustments required within the contract. So you know you've got the staff there to manage it and reduces ongoing issues for the next 30, 40 years, really, if you can nib it in the bud, as well as informing people. In terms of rehabilitation, well, really the same applies. Undertaking a short POE is going to identify these issues and feed into the next phase of the work. Obviously, you need to really see if your aims, if you've got criteria that you've set at the beginning, if those aims have been met. And too often we get briefs which say, you know, you need to perform this, this, and this, but nobody ever comes and checks whether it does. And so it seems a bit odd, you know, I'm sure if you went back to 90% of the houses that said they would have a SAP of you know, whatever it was, they wouldn't actually achieve that necessarily. Focus the money on issues where it needs to be addressed and disseminate information, but anonymously. I think that is key. You don't want the reservation of people saying, oh, I don't want bad things said about my project, and there's always that slight reservation. But we've really going to learn more by disseminating that information to everyone. Key questions: how much energy is a specific dwelling actually going to use? Comparing the standard assessment procedure against the actual income or the money that's spent on the house. If it's significantly different, you know, what's causing that difference? Is it to do with the fabric, use of the system, or behavioral aspects? What internal comfort conditions are being achieved? Can they be improved? Are there ways the building can be more efficient or offer other uses a better environment? Now, methodology, I think that's where Matt will come in, who's completed the study. Actually, I should mention that it was Rosalie Menon who actually carried out the interviews, but Matt has thankfully taken over in writing the report and bringing it all together. So, Matt.
Thank you very much, John. I'm going to run through the methodology that was developed for the project, and also some of the key results from this project, just to kind of illustrate the kind of things that John's been talking about, and that we hope to find out from it, and what the output can be. Okay, so the methodology, and again, as Tim said at the beginning, we're looking for this to be a kind of quick and dirty post-occupancy evaluation. There's quite a lot of methodologies for very intensive, maybe 2-year programs of post-occupancy evaluation methodologies, but we're looking for something that could be undertaken for a relatively short amount of time, relatively small demands on the residents, and also relatively short demands in terms of time for the people undertaking it and analysing it. Obviously, that methodology needs to be able to be extended for longer if any particular problems arise and more details required. So, the one that we, the methodology that we arrived at and then used, or then tested on these 8 different houses is really a 7-stage process. So, the first part of it is coordination with the housing association and the residents. Try and work out what the objectives of the study are from the housing association's point of view, identify residents who might be involved in it, and also gather the information needed for that study. So things like SAP calculations, drawings and specifications, so that we can understand what it is that we're kind of testing it against. In the second week, we'd install the survey equipment and sensors together with undertaking the resident survey. So this is actually, for the resident, this is the most time-consuming bit. There's maybe a couple of hours of installing all the bits, and we'll see those in a minute, installing all the bits. And then you want to sit down with the resident and go through a survey and try and find out their perceptions of how they use the house, find out what their routines are, and so on, as they are pertinent to the things that you're looking at in the housing, in the study, sorry. There's a 2-week survey period. That's for the actual sensors to be in the house. What we would be looking for is to try and get the energy bills over a year, so we can get a year's worth of energy bills, but only 2-week snapshot of actually what's going on in the house. So that's why when John was saying about where it fits in the process, we're looking at how there's triggers that perhaps, you know, we don't want the resident to go have to hunt in for all of their energy bills for the last year. So can we do it in the defect liability period of new housing, where the energy meter will have been set at the beginning, and you can go back a year later and take that reading. But the survey equipment's only in the house for 2 weeks, and again, there's a rough and readiness to that. those 2 weeks, there may be particular things that have gone on that are unusual or not typical, and you have to get that out or try and understand that from the resident while you're there. So the sensors are returned, and we've got 2 types of sensors in Meru, one of which you can put in a jiffy bag and send in the post. The other one comes in a big bag, and you need a couple of folk to go and carry it back. So we'll look at that. So then the survey data is collected. There's perhaps a follow-up phone call to the resident to look at, you look at all these graphs and all these numbers and go, well, what's that all about? Have the initial initial results available to view online, and then after that, and perhaps another discussion with the housing association, what we're looking at is some kind of either certificate or information sheet for the housing association and something for the resident as well, to say these are the things we've found, these are the things that you could do to optimize the efficiency of the house. There's maybe things that need to go back and be checked. So that comes out at the end there. So I'm just going to show you the 2 different types of test equipment, because these are really quite important, and they have a big bearing on the resident for a couple of weeks, and they have a bearing on what you can actually get out of the information. So you've got these LTEC transmitters and data loggers. They're quite big and bulky, but they can record temperature, relative humidity, and the internal air quality, the CO2 concentrations. And for one house, it's about £2,500 for a set of that. The key thing for the resident is that all those bits of equipment have to be plugged in. So for 2 weeks, you've got all these sensors around the house, all plugged into where the TV normally goes, where the kettle goes, and all that kind of thing. So you have to take that into account. Actually, that's one of the things that takes the time in the setup, getting all these things in the place that they don't. They look a bit like walkie-talkies. Walkie-talkies, and then this big data logger box, and they're all kind of spread around the house, and yeah, not the most aesthetically pleasing things, so we'll add that. Right, there's a second type of logger that is called a tiny tag. It's much smaller. It's very robust. You can put them outside, you can put them inside, but they only record temperature and relative humidity. So again, that initial step of saying to the housing association, what is it you're trying to get from this? What are we trying to understand? And can we do it with this? The main reason we like this is that they can actually be posted back by the residents. So you leave a jiffy bag with your address on it. At the end of 2 weeks, they just put it all in there and send it back. And they look like that, a lot smaller. They're just about that big. And as I say, very robust, but bright yellow. So they do stand out a bit. So you've got your information from the sensors. The other information you're looking for is kind of the drawings and the specification, the SAP calculations. The time with the resident for the survey, that's important. And that's one of the areas that we think, after testing this methodology, could be speeded up and can be improved. You've got to get the residents' fuel bills. And again, depending on where we are in the process, that could be made easier. And the key thing really is you've got to get access to the premises to mount and demount the sensors. And again, these are all fairly, let's say, mundane organizational issues, but these are the things that take the time in this method, in any of the methodologies, getting into the houses. So you prepare a monitoring strategy for each of the houses, install the equipment, interview the resident, then there's the data analysis. Ideally, all of these things would be done by the same person, so that they understood, they have the data in front of them, they have the questionnaire results, but also they've been to the house and they remember it was sunny on that particular side into that window, and that room was used by the dog, and all that kind of stuff. Then you can write a report on the advice and obviously travel time. Show this as a snapshot of the residents' questionnaire. It's the one that we use is actually got a lot of questions on it, and then we take the ones that are specific to the house or the methodology that we're using. So we try and keep it to 20 questions, which again, the kind of things are, how do you find the controls? Do you use trickle vents? How do you find the ventilation system? how do you turn your, there's various different options for turning the heating system on and off. Do you just wait until the house is too hot and then turn the whole thing off, or do you use the thermostat and the TRVs to monitor all of that? So it's trying to get into that detail as to what actually is controlling all of this. The other thing that we developed as part of the methodology and as part of this project was this web-based feedback. And if I point to Craig in a Kickstart Online first, we should have a website up here. It's a
when we go back online, just apologise and say we won't do that again. Just make it
yeah. Okay. Yep. Okay. Very sorry about that. A first for a live web viewing thing on Kickstart, but unfortunately, fairly major crash after that. So yeah, we're all sorted now. Everything's fine. So yeah, the website. We think that could be an important reporting tool and could actually speed up the amount of the analysis of the data and transferring that knowledge to the housing association and to the residents. Right, next. Yeah, okay. Okay. So I'll carry on talking. Right, brilliant. There we go. Next. At the moment, we're looking at the financial. Obviously, time costs money. How can we make this cost to the commensurate with the amount of information that you get out of the project? So we're taking an average of about 14 hours per property at the moment. And that's including travel time, and that's including all the surveys and so on. Obviously, if you multiply that over a number of properties in the same area, you're reducing that. But then you're also quite oddly increasing it slightly because then you have to hang about while people kind of come and go and allow you into the houses. Through this project, we've seen some ways we can make this more efficient, and I have Tim's lovely iPad here, and being able to do more of the survey data recording and putting it all into a form whilst you're on site. That obviously reduces the amount of time in the office, and also this web page we think is quite important for that. It standardizes the output, if you like, and allows you to transfer that to people a lot quicker as after the survey's been done. One thing I will say is that the interpretation, whilst actually setting up the property just requires a little bit of experience, the interpretation does require some experience, and also the knowledge of the questionnaire and being at the questionnaire seems to be quite important, that those two things are linked. So that makes that you can't just send anyone out to put the sensors in and ask the questionnaire and then expect to get good results when you get back. Obviously, said about the houses. So we took this methodology. We've seen some improvements in it, and we looked at eight houses with the 19 residents, 4 different housing associations, and 4 different architects. And we tested this methodology on these, and I'm going to show you some of the results. It's perhaps not really to show you the results as they are per house and so on, but to show you the kind of things that we can bring out of this. One thing I will say is that there were only two properties that we tested the same type, if you see what I mean. So in the rest, we were comparing apples and pears, one type against another type, and actually that's probably one of the things that kind of the obvious things coming out of this is that you do want to have some comparisons, and you have to do more in order to get a level of understanding. So these are 2 houses by John Gilbert Architects up at Glenmore, and these were code level 4 and 48% less carbon emissions than the building standards at the time, he says. So we looked at the energy. The first one's the energy. What we'll say is that the other thing about this is some of the houses we did get 11 months of a bill, and some of them we only got 7 months of a bill. So we're only showing you the ones that we've actually got something that's robust and reliable to base it on. So this shows you the SAP, and it also shows you the actual energy as we measured it. But these houses have got a wood-burning stove as part of their heating system, the main part of the heating system, and it's all electric everywhere else. The all electric bit is really easy to check. The wood-burning stove is probably that there, or probably that there. The thing is, we didn't measure how much timber they burnt over this period, so there's going to be a gap. These were always going to be look better than they are because we haven't measured that energy, and that is the primary heating. I think what we can say in this is that the 2 houses with very similar occupancy are using the houses in very similar ways, and they're getting very similar energy results. I think that's something that you can draw from that graph. Doesn't include the energy from the stove and is extrapolated from 11 months. The other thing that we found in this house, and this is perhaps related to the timber stove, is that compared to the other 7 house types, the living room CO2 was higher than the other 7 house types. So that's perhaps to do, as I say, to do with the wood-burning stove in that room. And you can see that there is actually a difference in temperature, average temperature between the 2 houses. But again, would that be taken up by the amount of timber that's used in the stove rather than energy in the electric? So there we go. Right, energy use was lower than expected. Stove couldn't be quantified. The internal air quality was poorer than expected. One of the things that came out of the questionnaires was that neither house used the trickle ventilation. There was clothes that were dried internally during this time as well, contributing to the relative humidity. And also, as I say, we're wondering about whether there's any contribution from the stove in any way at all. We haven't got any detail on that, but I think that's an issue to go back and to talk to the resident about and say, particularly about the trickle ventilation in the living room and how that works, and maybe that's not being used effectively to help with the air quality. So on to Fern Hill, and again, this is one where we took two side by side, or two relatively similar houses. And I think this is a really good illustration that the smaller sample size you've got, the more unreliable the results. These are two similar houses with similar occupancy, and yet the difference in the actual energy use is quite dramatic. That can't be down to the fabric of the building because it's the same. So that's down to differences in the way the buildings are used. And so if we were going to do this again on a wider, use the methodology again, then I think we would propose using as many house types, similar house types as possible to get a better understanding. That's just what I've just said. One of the things that we did notice in this and in other projects is that where the bedroom temperature is higher, the energy use tends to be higher. So where you compare two houses, if they have a high bedroom temperature, then the living room temperature actually doesn't seem to make a huge amount of difference, but the bedroom temperature does make a difference or is correlated to a difference in energy use. And again, this is really not to go into this in a lot of detail, but you can see from these two survey results that there's actually quite a dramatic difference between the way that each house uses their heating system and their ventilation. And it's a hypothesis that the house that used more energy has got its heating system on longer and opens its windows for ventilation, which kind of came out of the questionnaire a lot more often than the house that uses energy. It's got lower energy. It's a fairly basic assumption, although this doesn't seem to, well, they open the houses every day in winter, but they say they turn down the radiator appliance. Sometimes it doesn't quite correlate, but that seems to be what's going on in that house. The other thing that we think in this is obviously, it's easy to say, well, it's the user that's not using the house right. Actually, what we think is that there's a lot of controls that don't allow people to understand what they do and the fine level of control that they need to operate the house. So it's perhaps that the controls in one of the houses didn't allow people to understand that the heating system is still on, and yet they've got the windows open, or or how to use it and the temperature differences and so on. Again, it's a common thing we found through this was that the trickle ventilation was used very little, and that windows were open for ventilation. That was the primary ventilation method. Lockfield Road. We didn't have a comparison here, but one of the things we did find in the survey was that, rather weirdly, for very well insulated buildings, very efficient, was that they were using additional heaters in the lounge. Again, is that an issue about warmth, or is it actually an issue about the fact that people couldn't balance the heating system with the controls in order to allow them to have the temperature that they wanted in the lounge and not have the heat elsewhere? And that obviously, I mean, once you start getting additional heating, you obviously get additional energy use. There is two in this, sorry, there's two in this. Again, you can see here, this is looking at the bedroom temperature and the correlation with energy use, although admittedly the living room temperature is quite high here as well. But that seems to be a common thing in this study. Right. And actually, in this survey, there was an interesting thing about trickle ventilation, in that they never used trickle ventilation because it was too high for them to reach. So they couldn't use trickle ventilation. And that seems to be, yeah, that's a very particular thing, but you know, the controls don't suit the user. I mean, it's quite an obvious example, really, isn't it? Yeah, and again, this house is opening a window and turning the system on and off. That could be the simplest thing for them to do and to understand. And there's obviously an energy difference, higher energy use than this one, which is starting to turn down the radiators and use the TRVs to change the temperature. In some ways, you kind of look at all this stuff, and when you've got all these numbers, they kind of obvious things kind of like that kind of jump out at you, and you kind of, oh, it's a little bit obvious. But you know, when you look at the effects of all these things, it makes a big difference. The very small things seem to make a big difference. Yeah, higher temperature leading to higher fuel bills. I think it's fair to say that actually the SAP on these houses was particularly low compared to the others for the floor area, and we think that there's solar panels on these, and that's obviously making a big difference. But the kilowatt hours is still high. You know, the actual energy use to the predicted use, there's still a difference. I think that's a fair point. Again, this is a single flat. Actually, this only had 9 months of energy bills. This is quite interesting because the owner was in, or the resident was in the flat all the time for this one, and was a smoker, and we had a very big discussion about the contribution of smokers to CO2 measurement. But in actual fact, it did quite well in terms of CO2. So yeah, there's a whole very, very complicated thing. Colin went and did a very complicated calculation to work out the contribution. Anyway, I think the point here is that there were some spikes in the living room temperature in this that were noted, and it was Rosalie who went to the house, and therefore I don't know the exact orientation, how the windows all were, but we think that's contribution. There's solar gain in some sort in particular times during the day, and the living room is seeing really big spikes, and then obviously the windows opening to get rid of that heat. And again, you wonder if in the winter that still happens, and whether there's heat being kind of being dumped out through that. It depends on the particular flat. It's only a bit of a hypothesis, but that's probably the main thing to note from this was that it seemed to be quite a lot of solar gain. Oh, there we go. There's a big variations in temperature across the time, and not necessarily associated with opening all the windows, because that would be quite a sharp drop. And actually, if I just go backwards and forwards between them, the change in living room air quality occurs at those peaks in the temperature as well. So there's two things that's happening. Okay, so we could do again a full set of energy bills for the year. The thermostat seemed to be set very high. All the temperatures were very high in this. The survey said there's no evidence of the use of TRVs. Background ventilation again, windows being opened for ventilation rather than trickle vents. Again, the comment there was about drafts and creating drafts near the windows. And I think this one in particular highlighted that occasionally, just our methodology, sometimes you don't get enough information to be able to draw any firm conclusions, and that this is possibly somewhere where we have to go and have another look, or maybe interview the resident again, or do something else. It's kind of, and I think that kind of says that our methodology is as short as it can be. Any shorter, and we get a lot more of this. Whereas, out of 8, we've got one that we kind of feel there's not really enough there. So the last one again is a single house. This is in air, and high occupancy. Again, this had additional heating appliances in their survey response in the living room. So we're obviously expecting the SAP to be high because of that. although the average living room temperature isn't it's actually that high. You'll see again a higher sound. We've also got higher bedroom temperature, which yeah, kind of ties through. And again, there's questions about the controls and whether those controls, you know, if they're only using the thermostat to control the heating system rather than looking at the TRVs as well, that might lead to the bedrooms being particularly warm during the day. They did say this house has got mechanical ventilation. The occupants said that they turned it off because it caused drafts, and they didn't use mechanical ventilation at all. So that's an interesting bit of feedback, particularly at a time when the building regulations are really starting to push a lot of people towards mechanical ventilation and heat recovery. And I think the thing that comes from that is looking at how that's implemented and the controls available to people. If it's simply that there's only an on and off, then you know, people may well turn it off. If there's more control over that ventilation, then that might mean that it's still kept on. I've got another note here saying we need more on this one. I think there's need more in this development actually. I think it's another comparison. We're quite aware we've just got a snapshot of one house. We've got nothing really to compare it to. So we could do with some more in that development to be able to draw any conclusions on the fabric or anything like that. So overall, after all that, excuse me, we're seeing wide variations in the energy use compared to SAP, taking into account appliances and so on. I think, and that's we can see a number of different factors. There's perhaps user behavior as one thing. There's controls as another aspect to that. That having more people in the house and having people in the house 24 hours a day as opposed to evenings and mornings didn't necessarily lead to higher bills, which I think is, when you look at them overall, there were some that were definitely occupied for 24 hours and are relatively similar to SAP, and there's some that are occupied you know, morning and night and are relatively similar to SAP. So you know, you can get you know, the occupation wasn't necessarily a big factor. Obviously, having the living room high living room temperatures and the windows open is associated with high energy use, and that's fairly straightforward. And as I say, this idea that having a cool bedroom temperature is associated with lower energy use. I think that actually comes down to the controls, and that people in those houses have got the balance with the TRVs and the thermostats and so on. And people in the other houses have perhaps not been able to refine that to that level. And I think it has to say that throughout the use of trickle ventilation was poorly understood, and you know, even to that house that said you know, they couldn't reach the trickle ventilation. So I think that's you know, kind of background ventilation is an issue. And in terms of the methodology, what did we find out from testing it about all this methodology? Well, there's several properties of the same type should be compared. I think that's you know, as far as possible, that's an important thing. We can't get good results from one house and not be able to rule out you know, all these differences in behaviours and so on. So the more houses we get, then the better data we've got. Obtaining the energy bills is a necessity, presuming you want to look at energy, but obtaining those bills is a necessity, and it's also one of the trickiest parts, unless there's some way of controlling it, such as doing it at the time where you know when the energy, you know, what the meter reading was at the end of the project, and you know what it was yeah, a year later. It's definitely a snapshot, and that's the important thing. So actually a lot of the information that you can draw out of this comes down to the analysis and understanding the survey and the results together, rather than a whole big, huge, you know, 2-year survey that takes everything in, and you can kind of look more at trends. You've got to look at some very detailed things and try and draw some conclusions out of it. So all of this is all caveated with, it was 2 weeks, and you know, if things change after that, then you know, it'll change again. What we've found in discussions with architects and people in the client teams for these projects is that it provides them feedback, and that feedback is valuable and is useful for them going forward and designing new developments and so on. And there is actually value in this, particularly, as I say, the web thing that's a little bit easier to understand and has got a few quite clear outcomes. And the basis for more detailed evaluation, well, I think that's the methodology that we've got is that, and using the sensors, that can be extended over time, and that's a kind of recognized thing. So, and we think that it can be extended if it needs to be and become more detailed, maybe in particular houses or in particular places. That's a detailed thing. So I think I've run through a lot of that, and I think I'm going to hand over to Tim just now to kind of say kind of an overview and find a few words. That's all right.
Okay, thank you. The interesting thing about this is that you're getting quite detailed information, and the thing about doing it over 2 weeks is it is a snapshot, but it's in a sense you've got a narrow and deep study as opposed to sort of getting average temperatures over a year. What's important about that is that you can do that in conjunction with the survey and actually talking to people and get this real insight into actual kind of behaviour. And it's at that level of detail that we need to be operating, because as you're getting into low energy buildings, you're much more fine-tuning things. And so the implications of these things are to do with some aspects in relation to user behaviour. And you can sort of say, yes, people are behaving badly. They're not necessarily behaving badly. They're just living in a house. You know, they're just trying to do their best. And some of those things are just determined by the nature of the house. It has a particular volume, it has particular equipment in it, has particular sizes, windows, trickle vents, things like that. And so they're trying to operate it in a particular way. So there are implications, therefore, in terms of potential refurbishment. Could you change the nature of the background ventilation? Why was there a draft from that mechanical system? Is the vent just in the wrong place? Is it running too quickly? Is there some change there? But there are then implications in terms of, well, what does this mean for building design? You know, should we be designing some robustness into these into buildings so that people can behave in a sense fairly normally? The bedroom thing is interesting because what you're getting, I think, is changes in behaviour, which is not necessarily that people sleep at night with the radiators turned on, but they tend to use their bedrooms more. As housing volumes have got smaller, people tend to use more of the rooms all the time, and so they will live in their bedrooms. You know, so these sorts of behaviours, you know, have implications in terms of how we deal with design. We think that, notwithstanding there were issues about this, as this was a pilot, so we weren't in a sense doing a full data gathering exercise for these particular housing developments. So what you can do is you can compare a house in one scheme with a house in another and see, well, that one's got high temperatures and high energy use, and this one hasn't. So it's a measure of different types of houses to some degree, but also different types of occupancy, but also different types of usage. And so you can kind of compare across those things. If you were sort of doing this in a more kind of routine manner, then you'd be looking to get a reasonable number of sample houses in each scheme. You know, maybe sort of a minimum of sort of 6, 8, something like that, just to kind of give you a good kind of cross-reference. That would depend on the scheme to a certain degree. If you've got a scheme which has got lots of different house types, for example, end terraces and flats and whatever, you might want to think about that. But it gives you that very kind of clear picture. I mean, the other kind of interesting things are this issue about SAP, because SAP isn't a predictor of performance. It's a like-for-like comparison between this house and that house in terms of its at a design stage. It's not there to tell you how the house is going to be used. But this does start to sort of make people think a little bit about, well, how do we design the house for use so that people can sort of make changes. Controls are clearly a kind of a big part of that. The other kind of issue is how this all gets fed back, and Matt's talked about that. I mean, there needs to be a closing of this loop, and that's probably the biggest and most important aspect of this, which is you've got to get that information back to occupants, because there may be, in a sense, if people want to use their house badly, you can't stop them. But if they're doing it through ignorance, for example, in the nicest possible way, just not knowing how a particular kind of bit of kit works, then there are possibilities of correcting that, of providing information. We did a piece of work just recently looking at advice for occupants of low energy houses in terms of easy advice of how to use equipment, particularly equipment which is not going to be familiar to people. People sort of may know about an open fire, they may know a little bit about a central heating system. They don't know very much about programmers. They don't know very much about ground source heat pumps. Is that white box in the corner a fridge or is it a heat pump? So giving people advice on how these things work is going to be kind of part of that equation. The other thing is that the feedback loops, therefore, are to the occupants, they're to the housing associations in terms of things which they might do in those houses and things which they might do in future houses, and obviously to feedback to architects and designers, and possibly actually also to regulatory bodies in terms of the kind of standards we set for housing. And so one of the questions is, well, should this be part of building standards, for example, the ability to do POE? That's pretty much us, I think. We've got time for questions and a short discussion, and people may feel free to ask questions. And you can ask any of us questions. We've all got microphones, I think.
Thank you very much to all our speakers. I will now take questions, and you are welcome to sit back there.
Okay, thank you.
We will invite questions from the audience here and online. And we immediately have questions here in the audience. Could you please introduce yourself and tell us where you're from, and please say your question.
Emma Morton from Strathclyde University. I'm really interested in what you said about control, and I'm interested in what technologies that you were testing to look at the heat demand within the properties, and whether there was a change with new technologies, because as you're saying, if the more complicated we make the heating systems through ground source heat pumps and other technologies, the more complicated it is going to be for people to control that. So I was wondering if any of that came through in the research that you've done.
You got my mic, yeah? There's a very simple answer to that, which is that TRVs and programmers are a really rubbish way of controlling heating in housing. And no one knows how to use a programmer. And they're often badly set and those sorts of things. And there's an interesting thing about how those things are designed and how they're procured. Because they're not designed for users, they're designed for installers. And so there's an interesting kind of, there's an interesting bit of work to be done there about having different types of control systems. We didn't sort of test those things in that sense, but we looked at, it's a very, very common theme. It came out in all these kind of projects and lots of projects that we've done previously. The ability for people to intuitively control their house is a problem. And if you need to read a 10-page manual to control your house, that really doesn't do it. So there's something about either if you need a degree of active control, it needs to be intuitive. But if you can design ways in which some things are more passive, then that's probably going to be beneficial as well.
Okay, we have a question here, please. First, please introduce yourself.
Hello, it's Rose. Is it working? Okay, sorry, it's Rose Stellis from Shire Housing. We actually were one of the associations that you visited. Unfortunately, I wasn't present at the time. But on a similar study that we undertook in another development, which I was working with the researchers on that, we discovered that although that research was taken over a much longer period of time, and we talked about the pros and cons on that, there seems to be an issue with the feedback to the residents and actually the ability for them to understand how that is going to have an impact on just the basic things, such as the cost of them running their house, for example, the basic thing. Have you, for example, undertaken a sort of additional level of monitoring, sort of going back afterwards, once you've given the feedback to residents and associations, when possibly people have learnt things from the studies you've undertaken? Have you done that monitoring ever, following up, and have you noticed a change to that in terms of the energy use and the cost for the residents? Or is this something which is just not practical and just too costly to undertake?
Well, it's not something we did as part of this project. It's not something we've done, but it's something we would very much like to do. I mean, what that perhaps illustrates is that firstly, this isn't being done terribly often, and secondly, the loop often isn't being closed. You're not doing that thing about going back and giving the feedback and then going back afterwards and seeing if that's worked. That goes back to the thing I said earlier about sort of doing experiments but not looking at the results. So I think that'd be a useful thing. I mean, again, that comes down to a certain degree to do with the cost and practicality of doing this. Again, this is why it's one of the benefits of this particular methodology is because it's quick and cheap. You could do a 2-week tranche, you could give them advice, you could go back in 6 months' time or a year's time and do it again and see if there has been, you know, a kind of difference.
The other thing in that, if I just need to, I'll just talk. Yeah, grand. The other thing in that is if you collect the data over a number of houses, and you could go back and say, well, you know, you kind of take the personality out of the data, if you like, rather than saying it's your house and you know, this is your result and this is what should be done. So, well, these are all the same house types. We've got 4, and you're the highest. And these are the kind of things that people said in the survey that made them, you know, use lower bills. So if you were looking to do that, whereas if you've just got one house or you've got, you know, 2 houses, then you say, well, the guy next door does this and you do that, and you're kind of in this kind of odd. You're dealing with people, not just numbers. And so it would be useful to have more data, so you can say, you take the people element out. This is the kind of thing that's.
I suppose as a housing association, you could just regularly monitor the energy usage in the house each year, and if there was huge amount of energy use, you would go back and speak to people about it. But it's a bit like being a sort of modern Octavia Hill, going back and checking the energy all the time of that house, the energy use of it.
But it's not just about energy. I think that's the important thing. I mean, one of the things that you're getting from this is things like air quality. And again, that's why we sort of favoured the LTEC systems, because they're a bit heavier and harder to do, but you get that better quality information. Because that's one of the concerns. You may get things which aren't using very much energy, but if the environmental quality is poor, relative humidities are high, you're getting damp, even in low energy houses, having those sorts of problems, then that's a contemporary issue. Actually, it's a contemporary problem. So it's something that anybody would want to get information about. So yes, I mean, I think it's not just about energy. I mean, that's why we're interested in sort of environmental, comfort and environmental kind of qualities as well.
Yes, question here in the first row, please.
Charlie Russell. My question is to do with, I've actually been involved in a study looking at something similar, and collecting the data off residents is actually quite a task. So just to acknowledge that, it's quite a big thing to do. And one of the things that we noticed was that quite often householders are on estimated bills by their energy companies for the first year, so they may actually be paying over. And if it's just done by the estimated, I just wanted to ask if that was something that you encountered, or it did seem that there was quite high for all of them. And
kind of phone a friend who knows the lay and find out. I don't. The honest answer is I don't know whether that was something that came up in this, and it may be a reason why some of the periods were incomplete in this. The billing periods, getting the bills out of people, getting the bill information was one of the biggest things, and also finding a mutually agreeable time to meet with residents, sit down for an hour or half an hour, whatever it is, and go through the survey. And residents being there when you turn up at the allotted time.
Yes.
Yeah. A couple of things there. I mean, one of the things you can obviously do is you can take meter readings. You can do that for the period of the study, and you could do that for a longer period as well if you needed to. You don't have to translate that into bills. And so just going back to a previous question, one of the bits about feedback is that we've looked at things like kilowatt hours. In terms of feeding back to residents, you might want to convert that to money, something kind of more realistic. The other thing to touch on, which you've also raised, is the issue of actually getting into the houses at all, because that's quite difficult. We rely fairly heavily on the association to facilitate that, and that's kind of quite an important aspect. It is part of the kind of methodology that we do provide incentives to householders, so we give them vouchers, or there's something which helps to get them involved, and that's an important kind of aspect of it. There has been some discussion about whether an association, particularly on a new build, might write it into an agreement, into a tenancy agreement. Jurists have out on that. People are concerned that that might be kind of too heavy-handed, but you need to sort of look at ways of actually getting access to the houses that you want to see.
Yeah, I think that's a good point. Giving an incentive, a Marks and Spencer's token or something that people get after they've basically finished and they've kept the equipment on over that period, because we did find the odd one actually switched off. Not really maybe realizing the importance of it. Or also you can get them to send it back in post, and that would save at least the smaller devices. And if they got a reward for that, then I think that would be well worth it. And it would be a small cost of the total.
I think the whole feedback thing, development work for both things, so that actually we can, rather than sending some paper reports or something like that, actually something a bit more interactive, so people can make these links between the three different things that we're measuring or whatever, and maybe looking at other types of houses, other similar types of houses, being able to show them, that might help with some of that feedback.
Okay, we have some questions from our audience, and one is related to what has been discussed. Question from Mohammed Abdul Wahab. How did you go about selecting the residents who participated in the study, and what challenges did you face when collecting the data? Anything else that you would like to add as a comment to this question?
Yeah, we've maybe just sort of answered that a little bit. I mean, this housing association, generally speaking, approach the residents on our behalf. In other schemes, we've used other ways of doing that. We've done it by, sometimes we've leafleted. There's a project we're doing in which we might, it's a slightly different project, but we might go in through health centres, local health centres, for example. It's a different type of project, but it's a way of getting addresses and getting letters into people. But generally speaking, for something like this, you would obviously want to be working with the client, with the housing association. So that would be the principal way of doing that.
Another question from Brian McAllister. You noted occupancy didn't necessarily affect energy use. Did any houses use night storage heaters, as their energy is not affected so much by occupancy?
Yes. First answer. Actually, it's an interesting thing. The Glenmore houses, the first houses had the wood burning stove as the main system, and then they had electric storage heaters as a kind of backup system. And in terms of user controls, the fire is either on or off, and electric storage heaters are set, and you just leave them alone, and that's pretty much. And both of those houses came out with very similar energy uses, and you wonder if the intuitive nature of the fact you put the fire on or you don't actually contributed to those being quite even. But that one did, and as far as I know, although I didn't go to all of the houses, so I don't know. I think the rest had gas systems. From what I can remember, I can't remember any other systems.
Okay, quite a lot of questions. Let's try to answer. For example, from Nick Taylor, it was mentioned that people heat their houses up to a limit set by income. How good a correlation is this, and is it affected by occupancy?
Yes, there was quite a good correlation to that, and actually that's something we've seen very commonly, particularly in refurbishment, where people live in kind of quite poor houses and spend a certain amount on fuel up to sort of an economic limit, and then when they come back into houses, they spend the same amount of money, but in a sense they're achieving better comfort conditions. Sometimes it seems that they are overheating, in the sense that they are. Average temperatures are quite high. There's lots of window opening. Relatively little kind of control. So yes, that is quite that's quite apparent.
Mm-hmm. Next question from Misha Jack. What would be the cost of carrying out this type of post-occupancy evaluation?
Well, the obvious answer is it depends.
It depends who's doing it. I think,
yeah. I mean, what we're trying to, what we were looking about, if you go back to the sort of the figure of sort of 14 hours per house, that then depends on the number of houses. It depends on some other factors to do with kind of distance and complexity and so on. But I think we would be wanting to try and get these things as a ballpark figure, a rough ballpark figure that something around about the sort of £5,000 mark. £5,000-10,000, something like that, is within a reasonable kind of scope for doing something like that. It obviously will depend on the amount of houses you're doing and some other aspects, but it's something. The obvious idea is trying to make it reasonably affordable.
That's for more than one house.
Yes.
Yes. That's for say a group of sort of 8 to 10 houses, something like that.
Question from Kevin Bowie. Were the occupants that lived in lower energy consuming houses occupants that had a better understanding of their heating controls happier, more comfortable in their environment?
I don't think we had a question on happiness.
No, we don't have that. We should. This is the...
Well, yes, we didn't ask about happiness in this study, although interestingly, that is something that we're doing elsewhere, and it's something that we have talked about actually putting into these studies, is questions about, at the risk of sounding a bit current, well-being. And there are a lot of questions we could ask. We could ask about all sorts of things, and acoustics and satisfaction, and is the water pressure good enough? All those sorts of things. The trouble is, the more questions you ask, the more time the survey takes, the more obtrusive it is. So this is really kind of trying to keep it as concentrated as possible.
A question from Duncan Campbell. As the survey period is narrow, the data obtained will be affected by the timing. Mm-hmm. For example, summer or winter. Is the data adjusted for this?
We're doing these in a heating season, and we're always targeting a heating season, in order to get a reasonable picture of how people are using their heating system. So that's it. There wouldn't be any problem other than the fact it would take time and therefore cost money to do several slices. And we have been talking with sort of other groups, associations, the fact that we might, for example, do say 3 slices a year, sort of winter, spring, autumn, and summer. So you could do something in different seasonal conditions if you thought there was a particular issue or problem. Obviously, this has been focused primarily on energy use, so we are targeting the surveys over the winter. So that's the sort of de facto.
Question from Kenny Young. The cost of both sensors and monitors are coming down. Surely it would be possible to build these into new building housing, which would allow constant monitoring.
Yeah, it would be good. I mean, if we got smart metering, we're nearly halfway there in a way. But it doesn't, I suppose, take into account people's behaviour and how they look at the building, how they interact with the building. I think that's still a question that can be asked.
I don't know. I kind of feel that putting monitoring in housing permanently is kind of a bit of a step towards Big Brother. Perhaps people are reassured by the fact that there is a big thing there in the corner, and then it gets taken away at the end, and they can do what the hell they like and open the windows and I don't know. I would say there's a perception thing to that.
I mean, anecdotally, what I can say is that we've been involved in a couple of projects which what tends to happen is because the heating control systems are sometimes the last things to be fitted, they're often subject to fairly stringent financial restrictions, and so often that gets kind of cut, particular project involved in it got cut back right at the end. So there was a plan to put in something very sophisticated, and then it kind of got sliced right at the end. I mean, it's interesting because even quite sophisticated bits of kit, we're talking to some MVHR manufacturers who have various sensors within their equipment. It's not at the moment. It's not that good. You know, they've got some sensors, but they're not particularly good sensors. They're only in the duct. They've only just now started to think about, well, actually, there's no point in having a sensor in the duct. You need a sensor in the room in order to actuate, you know, the fan. So it's early days for that, and you know, I think there are kind of possibilities.
Here is some information from Carol Burswhistle from Leeds Metropolitan University. I will read for the benefit of our audience here. Leeds Met has been using the same LTEC equipment and running further user comparisons at Stamford Brook with the support of the National Trust. We found a massive range of energy use from 3,000 kilowatt hours to 40,000 kilowatt hours per annum for a similar set of properties. We recruited some local tenants as meter readers to go and get a weekly set of meter readings from 60 properties. We have also seen a lot of problems with ground source heat pump controls in another project have been a real problem for users to adjust. So that's a bit of more information on what's going on in research across universities and United Kingdom. But here is one more question from Gillian Henley. How do you think you could convince private clients into investing in POE, in post-occupancy evaluation?
Well, I think actually, I'm thinking of that as private house builders rather than private individual clients. But you know, they've got a lot to gain from knowing how their product is and improving it, and product improvement, if you like, and also with the change in building regulations that's coming, then you know, energy use and is certainly something that they need to learn to improve.
Yeah, it's interesting. I was thinking this might have come up as a question, which is to do with, in a sense, who owns the data. And one incentive for a private developer to do it might be that it would be better for them they might feel more comfortable if they were going to do it. They would get the information that they could act on rather than someone else coming and doing it and it being more public. That might be just a lever for them in that sense. Because there are, you know, anybody in theory, if any housing development, anybody could set up a study to go and do POE and look at its performance, and you know, there will be very similar issues. I mean, the house design is not so significantly different now between social and private housing. So, you know, that might be a lever for them to do it. I mean, I think also we are in this place where there are innovative new technologies, and the question is, you know, are they working properly? Are they working well? I mean, interesting point made in the last question about heat pumps, for example. A lot of anecdotal evidence, you know, of people having problems with them and the efficiency is not being so great and so on. So, you know, if private developers are putting these things in, they want to be sure that they're working well. So I think there is an incentive there.
I mean, I think there could still be legislation for larger housing projects. We have it for air tightness testing, sound testing, but you know, if you were building 50 houses or more, I think there could be an obligation on the developer to carry out some kind of POE to monitor that energy consumption to show that it is meeting the performance that was set for that project.
Yes. A question from Ruth Dwyer. What level of CO2 is the benchmark for healthy air quality, and what was the equipment you used to measure this?
We're looking at a figure of 1,000 parts per million. CO2 is a marker of air quality. You may have other factors within the air, pathogens, things like that. But if you've got a high CO2 level, that's implying that you're not getting a good air change rate, which is implying very good implication that the air quality levels are low. We were using the LTEC loggers to do that. They've got CO2 sensors on them.
I mean, there was no special. I mean, apart from the housing association saying to the tenants, "Well, this is the house," I doubt if they went round and said how the trickle vents work. You know, which actually is probably something they should be doing, or how the windows are opened and can be put on a night latch. Those sorts of little things, which we're finding are really something you have to do, and you have to label, and not assume that people know these things.
That is related to the next question from Ola Uduku. Had the residents had some kind of training scheme to understand how to use the environmental control systems in their houses beforehand?
I mean, not that we're aware of, apart from the normal introduction to a house that whether the architect or the housing assistant might have given it, and they would have had a handbook, obviously, about the house. But we wouldn't know. I don't think we collected the information before that. Speaking on behalf of everyone.
I can comment on probably what happens across the board. At completion, all occupants are given information regarding how the house operates as part of sort of tenant's pack. But the nature of this is that people move in, there's lots of pieces of paper, then there'll be some verbal exchange between the person signing up and giving the keys there, and there may be some information, kind of teething problems of the first couple of days when they're moving in, but there's not normally an extensive program of induction, so to speak, but people do come back to us, and we do try as much as possible to kind of refer people to documents and give them advice and support. But I would think most associations probably don't carry out kind of training per se. But that's a weakness, and that's probably why this kind of study actually is very valuable, because it gives a focus to staff to realise that these instructions are vital to make sure people are living the best way possible in their new homes. So.
Yes. Another question.
I was just going to say that
we do have a solution for that.
there is the changes to the building regulations in May, section 7 for sustainability, about the sustainability labelling. The higher levels of that will have a mandatory standard for information for residents, both private and public, whoever moving into houses, and that's the standard of information you've got to give.
And I think, you've done the research for building standards, and I think there'll be a downloadable example that you'd be able to get.
I mentioned this earlier. We did a piece of work for building standards to produce some guidance for occupants of low-energy houses. And the thing we came up with is a sort of quick start guide. So something kind of quite small, quite graphic, quite nice looking, that people would tend to keep. So not the sort of 50-page A4, ring bound thing that you can never find information. And we can probably make the link to that available after this.
Yeah. Next question from Chris Fowles. Regarding data collection from sensors, you obviously use a 2-week period, but how long is typical in other post-occupancy evaluations? Is there a best practice minimum?
It depends. For example, the Technology Strategy Board Building Performance Evaluation Program, which is open at the moment, and I might share a link to it at some point, is funding quite a substantial POE in both domestic and non-domestic properties. They have a requirement for a 2-year monitoring process. It's a different type of thing. They fund that. There's significant support for it, but they're looking at a 2-year period. That's obviously quite a lot of data you're going to produce from that. And whilst it would be very good at sort of giving you a long-term picture and kind of broad averages, and it would help to identify kind of trends, getting down to the sort of level of detail, which you really need, you need to get into an individual day. It's a day in the life of a house, really, that you make these sorts of changes. In an ideal world, you would do these things over a year, then you get a full season's data. You would be able to kind of correlate it for kind of different weather conditions and so on. But you are balancing, the amount of data you're gathering against how you can actually then kind of analyze it.
And also that idea of taking snapshots at different times. I think the response to the questions in different seasons. So you would have to go and do all that as well as just putting the sensors in, and making it. You're actually getting the hard data. You've still got to get these different things that happen different times of the year from the resident.
Okay, comment and a question from Kevin Bow. To optimize the building, removing control from end user is the obvious choice, as occupants have limited understanding of controls, as shown by your study. Removing end user control of the building will cause unrest to the end user and thus invalidate the optimization of the building as the comfort criteria are affected. From your study, what would you conclude is the optimal solution to optimize buildings for minimal cost, training occupants versus installation cost versus occupants' comfort?
Well, that's a small question.
I'm just trying to phrase an answer to that. I mean, I don't think that the answer is to remove controls. I think it's just to have better controls. And that those controls may be more passive. People will still control their building because they will change their behaviour. It didn't really work when we made offices sealed and people couldn't open the windows because, in a sense, there was a psychological problem with that as much as an environmental problem. And I think that's even more the case in housing. People feel, do I think need to have an interaction to deal with, just things which happen in a house. It gets hot, it gets stuffy, it gets smelly. You're cooking cabbage, whatever it is. People have to interact to change these things. At the moment, people tend to, I mean, this is a huge generalization, but people tend to do the more obvious thing, the thing which has the biggest and the most immediate impacts. If you're hot, opening a window is a psychological device as much as a kind of physical device. You could turn down the TRV, but there's no interaction. And so that's clearly a kind of problem.
Question from Dave Tremlin. Do you see this kind of study as a source of information on which to base a program of educating those whose income limits their energy use to the financial benefits of taking a more proactive role in controlling the way they use energy, rather than depending on others and passive controls to do that for them?
I think there's an interesting thing that people generally think that their house, if you move from either a cold leaky tenement or a cold leaky 1960s flat or house into a nice warm new house with gas central heating and double glazing and so on, and people will always feel that their house is performing really well, even if it, as transpired in this, they're using 3 times the amount of energy as their next door neighbour. They will always feel that their house is better. So I think being able to compare across a range of house types and say, well, look, this is where you sit, and you could, if you wanted to, if you chose to, you could reduce your energy bills do this. That's a
I mean, we certainly see this source of information. Thing that I've mentioned at the start. A way of there needs to be a feedback loop. So you get this information. It has to be a way of educating people. It gives you what it does is it gives you an evidential basis on which you can sort of tell people, show people things. The air quality is poor, the heating bill is high, the energy, the temperatures are very high, which I think is, gives you that kind of feedback to people, which is important.
Okay, well, I think we are now at the end of our seminar and webinar. I would like, first of all, to thank our speakers for their talks and answers, to thank our audience here for their questions and audience online. And I would like to use this opportunity also to remind you that our feasibility studies and academic consultancy funding is available, and that you can apply for funding and submit your applications by 13th of May. That's the next submission deadline. And then when your studies are completed, you would also have opportunity to present to the audience here and online. I would also like to remind you that our next seminar will be on independent verification of a climate-based worldwide building energy index. This study was undertaken by Glasgow Caledonian University, and the speakers will be Dr. Rohinton Emmanuel And another speaker is small to medium-sized enterprise that was involved in the study, IES Ltd from Glasgow, and the speaker will be Dara Gleeson. So this seminar and webinar will take place on Wednesday, 20th of April. We would like also to invite you to sponsor our seminars and webinars. If you would like to do that, please contact us and we will provide more information on sponsorship opportunities. Once again, thank you very much for watching. Thank you to our speakers, audience here and online, and I hope to see you again on Wednesday, 20th of April.